All right, welcome YouTube viewers. We've got a little uptick here in solar activity. We've got a little bit of increase in magnetohydrodynamic pressure around planet Earth. We'll be looking at the last 4 hours here on our Geospace Magnetosphere movie, where we've been starting out our in-depth daily space weather coverage. We'll also be looking at coronal holes and sunspots and solar flares and coronal mass ejections as we do daily. So this is magnetohydrodynamic pressure modeled in nanopascals by the Space Weather Modeling Framework. The past 4 hours have experienced some high pressure. In the earthly zone, out to about 12 Earth diameters is what you're looking at here. The sun would be off to your left. You're looking at a 90-degree tilt on the equatorial versus meridional planes. We'll also look at ground magnetic perturbations as we show daily. And again, we saw a brief geomagnetic storm here, and we can expect more geomagnetic storm conditions tomorrow on the 29th from about 3 o'clock Universal Time till about noon Universal Time. At the moment, a little bit of an uptick there in nanotesla at the ground level, Earth's magnetic moment from the ground, geospace delta B. So there you can see actually 2 periods of geomagnetic unrest. We do see a slightly heightened solar wind speed. We'll get to that. The radial flux has come down to 142 solar flux units, and we're currently in a period of geomagnetic unrest. It seems like it was chiefly a magnetic series of events. We don't see a super significant signal here on the real-time solar wind data. We do see a rather strong negative BZ here, but the field isn't that powerful. Up here, a little bit of a stronger negative BZ, that's the red line there in the top pane. But not that significant conditions. Again, we are expecting a high-speed coronal hole wind stream tomorrow early in the day Universal Time, and a period of about maybe 12 hours of geomagnetic unrest and geomagnetic storm conditions. Current conditions are for the solar wind density just under 9 protons per cubic centimeter. Solar wind speed a little bit elevated here at 503 kilometers per second. And perhaps we'll see a very high-speed stream. It is expected to be negative polarity, so that, again, increases the likelihood of geomagnetic storm conditions. Next, looking at the heliospheric current sheet. One of the best ways to forecast solar activity. It gives us insight into things that are completely invisible when looking at, for example, the SDO ultraviolet imagery of the chromosphere. This gives us serious predictive value. And we share it daily on the daily space weather videos because it's super important. Although basically the sun has been rather calm, it's been actually dropping down in activity here the past couple of days. And this looks like the arrival of some plasma right here. So you see these spiky sawtooth looking readings here on the GOES magnetometers. That is typically a plasma arrival type feature. Again, we are seeing a bit of an elevated solar wind speed here. Interesting divergence happening right here, where the GOES 16 saw higher readings and the GOES 17 saw lower readings as they approached noontime local time for the satellite, which is what these N's and M's are. Those are noon and midnight local time for the satellites. Here's the line of sight ecliptic plane field plot. It also shows the solar magnetogram as we watch the solar polar field reversal process progressing here during solar cycle 25. And here's a better view of that, the line of sight coronal hole plot. So you can see the sun's B field. Those blue lines are the sun's B field, the field that goes through the magnet, this magnet being the sun. And we are expecting the high-speed coronal hole wind stream from these South Pole-oriented coronal hole systems here that we just see rotating through. We forecasted it several days ago. It's a fairly well-defined coronal hole system. And we've got some new North Pole coronal holes rotating here in the east. Another interesting note is that the solar polar fields are still largely oriented at the poles. So you can see this rather consistent North Pole and South Pole feature there. Solar cycle 25 is taking its good old time for the solar polar field reversal process, which is really the main aspect of a solar cycle. It's not just sunspots, it's also the fields reversing. Here's your 193 angstroms wavelength from the SDO. An annoying calibration move going on there to keep the solar disk centered in the aperture. And it's great at viewing coronal holes. We've got lots of sunspots, so let's get into that next. Quite a lot of sunspots. They're not very big. The likelihood of flare is not all that high. They are not that complex. This sunspot up here needs a name. We covered it yesterday. That should be a sunspot 3002, as far as I can tell. It is beta class. It's degraded a little bit since yesterday, but it's certainly been there for more than 12 hours. So name that sunspot. If you've got theories as to what it's going to be named, it's going to be named 3002. If you've got theories as to what it's going to be named, let us know in the comments what you think it ought to be named. Perhaps you think it ought to be named Steve. I don't know. Just saying. Anyway, we've got a lot of sunspots. None of them are super big. 2993 and 2994 are still certainly capable of producing huge flares as they approach the limb, especially. Yeah, solar flares more likely at the limb than sort of in the earthly center of the solar disk. And let's move on to view those in 1700 angstroms. So some pretty decent sized sunspots here rotating in the southern hemisphere. That's 3000 and 3001 and 2999, I believe. Let's go back. Yeah, 2999 is this one, 3000 is this one, and 3001 is this one. So this one needs to be named 3002. And we have seen some flares here, no big flares, just some large C-class flares. We'll get into that in a minute. First, take a moment to press like and subscribe if you enjoy the content. Did you know we make all kinds of videos besides space weather? Yeah, there are videos about driving and riding bikes. Also some interesting videos about terms defined, some collabos with other creators. Shout out to Eugene the Philosopher. So press like, press subscribe, tell your friends and foes. No, I don't think Elon Musk has fixed the internet. Thanks to our subscribers on YouTube. Please give Smash staff a raise by visiting our own websites. We're also putting out meteorology segments on BitChute. Welcome to the Neo Renaissance. You can find lots of our links, maybe not all of them, but lots of our links, on the homepage at smashomash.com. Give Smash staff a raise by picking up some merch, maybe becoming a patron, but most of all, by joining the Smash team. So gold and silver members get additional content. No matter how bad things look, please don't pole vault the caldera. We don't want to see you become a part of the atmosphere or a part of a lava lake. So don't pole vault the caldera. It could be unhelpful. If you're going through hell, keep going. Don't worry, folks. Our finest days lie ahead. Things might seem bad, but it is up to you to make Earth not suck again. So please do not make Earth suck even more by pole vaulting the caldera. And give Smash staff a raise by picking up some merch or becoming a member of the Smash team. I don't think Twitter is fixed. We still have less than 250 followers over there. I think it's kind of hilarious that people think Twitter is fixed now because Elon Musk bought it. I think it's a humorous joke. We are on Twitch as well, doing daily live streams about space weather, usually 2 videos on space weather. And last but not least, if you want to support the channel, we replaced Patreon with a superior website, our own, which has superior capabilities. So check us out over at smashomash.com/smashteam. If you want to see all of our video content in one convenient location, just click posts. It doesn't require any kind of a membership. But again, if you want to support us, pick up a membership at the gold, silver, or gold annual paid-up subscription level. The gold annual paid-up subscription level includes some complimentary merch. No spikes in the proton flux here, despite a few significant C-class flares. And there is the flare profile over the past 3 days. So again, 2 significant flares here, nearly M-class. That was a C7.3, and that was a C6.7. Let's take a look at them visually. And I think my favorite wavelength to view solar flares is 94 angstroms. 131 angstroms is another good choice. It also takes 10 images per minute instead of only 2. And it looks like one of those C-class flares may have come out of Sunspot 2999. Not exactly sure, but again, the likelihood of major flares being produced by 2993 and 2994, which are these large setting groups here in the northwest, is probably the highest in terms of earthly visible sunspot groups. Continuing on, we're going to get to coronal mass ejections in a minute. There have been some. Are they directed at the Earth? We'll let you know. First, a star chart. As the planetary pileup continues, people are frightened and spooked and scared because the Moon, Jupiter, Venus, Mars, and Saturn are all visible near the ecliptic in the morning sky. Oh noes, planets. They're gonna kill you. Planets are gonna kill you, folks. Just kidding, folks. It's ridiculous. Planets are not going to kill you. But there's a star chart. That's what's going on over our head in the Lehigh Valley. My star chart faces the south. That's from in-the-sky.org. Here's a solar system forecast. Keep in mind this is not to scale. In other words, Jupiter and Saturn are actually very far apart. Did you know that Mars and Jupiter are closer together than Jupiter and Saturn, which are closer together than Saturn and Neptune, which are closer together than Neptune and Uranus? Yeah, there's a magnitudinal distance. All the planets are farther than each other, even proportionally speaking. Anyway, that's not to scale. Here's your 1 week forecast as we approach a new moon. Here's where things will be in a week on 5/5/2022. Last but not least, let's look at some coronal mass ejections. And we see some deceptive activity here. If you only look at the view from the Lagrange point 1, the location of the Soho-Lascaux C3, it may look like a halo. Is that an Earth-directed coronal mass ejection? Well, the answer is no. None of that ejecta is on the Earth line, as you can see here from stereo A. So going back to our diagram here, stereo A is located here at Lagrange 5, which puts Earth off to your right when viewing the Sun. And we don't really see any ejecta down that line. We do see a far side coronal mass ejection. That's what's making it look like a halo. So a prime example here of how deceptive looking at only the Soho-Lascaux C3 can be. The Soho coronagraphs place Earth behind you. Anyway, that's it. No coronal mass ejections headed toward Earth. There is a coronal hole high-speed stream on the way. We can expect a brief period of geomagnetic unrest and geomagnetic storm tomorrow. Thanks for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least posted name in news.